In this video, we will set up Modbus communication on an M172. Both slave and master cases will be discussed. The M172 has two onboard RS485 ports. One port can only be used as a slave. The second RS485 port can be configured as either slave or master. The M172 can only have one master port, but up to 3 slave ports. A third RS485 port can be added using a plugin. If the plugin is configured as master, the base controller cannot be master. After clicking on plugins, we can add the desired module via drag and drop from the catalog. As shown, this port can also be configured as master or slave. The Modbus slave settings for the RS485 port can be found in commissioning. Go to All Parameters, RS485 Port 1. Here you can configure the address, protocol, baud rate, stop bits, and parity. When the port is set as master, these parameters are not used. Instead, the configuration settings are applied. The same applies to the RS485 port in passive serial mode. Parameters defined in commissioning are not active at runtime. A device reboot is required. Alternatively, slave settings can be adjusted by defining custom default values in the parameters. We can select a parameter and change its default value. In this example, we change the address of port 2. Then we click Save. Returning to commissioning, we can see that the default value has been updated. During download, all default values can be written to the M172. It is also possible to change settings through programming. Programming-based configuration will be shown in another video. Now we will configure the Modbus master. Go to RS4. RS485 port 2 and set the mode to Modbus master. We can configure the baud rate of the network. Parity, data bits, and stop bits can also be set. The master supports 7 or 8 data bits. Now that the Modbus master is configured, we add a device. Drag a generic Modbus node onto RS485 port 2. Click on the added slave to configure it. Set the Modbus address and node number. The node number is a logical address used in programming. It can be used to manage the slave at runtime using system arrays such as node enable/disable, presence, and status. The node number ranges from 0 to 127. In this case, we set both the slave address and node number to 2. Now we add a Modbus message. Right-click the generic Modbus node and add a Modbus message. Supported Modbus function code 3 to read holding registers. The PLC supports up to 127 slaves. Up to 512 messages can be configured per PLC. The start address defines where reading begins on the slave. Polling time defines how often data is read. In this example, we set it to 500 milliseconds. If the timeout expires before a response is received, the operation fails. Wait before send defines the delay between requests. This delay is required by some slave devices. Next, we define where the read values will be stored. We first create variables to store the values. For example, read_hreg1 and read_hreg2. To assign variables, we must save the project first. Then we assign the variables using the Assign button. Up to 16 registers can be read in a single message. For read and write operations on the same register, write must be executed first. The PLC sends all write commands before read commands. If variables are not initialized, the PLC writes zeros by default. The address and variable must match for both read and write functions. If the slave is an actuator without display, or if configuration changes are not allowed, it is necessary to copy EEPROM parameter values into variables during startup.